So we're moving on to section 5.1, which is about discrete probability distributions. Discrete probability distributions. So first of all, we want to define the term, what is a random variable? A random variable, this is a characteristic that'll take on numerical values. And these numerical values depend on outcomes that are a result of chance, the result of chance. We'll get into some examples in a moment. First of all, there are two types of random variables. You can talk about discrete random variables. So these are random variables that generate data values that would be counting numbers. Counting numbers. Remember when we talked about discrete data? Discrete data involves counting numbers. And continuous random variables, they generate data values that involve decimals. So yeah, we've already discussed discrete data versus continuous data, right? Discrete data is just involving counting numbers. Continuous data involves decimals. So we're going to focus on discrete random variables today. We'll look at maybe some continuous random variables later down the road in chapter 6. But a discrete random variable is what we're focusing on today. So discrete random variable is a characteristic. It takes on numerical values that depend on outcomes that are a result of chance. And the data involves counting numbers, only counting numbers. So let me look at some examples here. Discrete random variables. Examples of discrete random variables. I don't know what that was about. So we often use the letter X for a discrete random variable. I don't know what this is doing. Okay, number 1. We're going to call X the number of siblings a selected student has. So the idea is I'm going to randomly select a student, and I'm going to call X the number of siblings that student has. So you might not have any siblings. You might be an only child. So in that case, X would be 0. Or I could select someone else, and you may have 1 sibling. So X would be 1. Or I could select someone else, and maybe you have 2 siblings. That person, we would say X equals 2 for that person. So it's random, right? It's based on chance. The value is based on chance. The outcome is based on chance, where the 0, 1, 2, 3, 4, however many siblings, it's based on chance because I'm randomly picking. And we're dealing with counting numbers, right? Only counting numbers. Since we're talking about siblings, you can't have parts of siblings. You can only have whole numbers or counting numbers. Okay, let's do another example. How about, let's say X were to be the number of heads that show up after a coin is tossed 10 times. After a coin is tossed 10 times. So if I toss a coin 10 times, I could get 0 heads, so X could be 0. I could get 1 head, so X could be 1. I could get 2 heads, so X could be 2. All the way to X could be equal to 10, right? That's the most X could be, because we could have 10 heads on 10 tosses. So in this case, X is your discrete random variable, right? Its values, its outcomes depend on chance, and they're whole numbers, right? So that's another example. Here's a number 3. Let's say you define X to be the sum. The sum when a pair of dice is rolled. When a pair of dice is rolled. So for example, if I rolled a pair of dice, the smallest sum I could get would be a 1 and a 1 would be 2, right? If I got 1 on one die and a 1 on the other die, I get 1 and 1 and 2. So that would be the smallest sum. The largest sum I could get is like a 6 and a 6 would be 12, right? It's the biggest. So that's determined by chance, right? My sum is determined by chance. And we can only get whole numbers, right? We can get like 2 through 12. You get like 2, 3, 4, 5, all the way up to 12. So these are counting numbers. Okay, so just some examples to give you an idea about discrete random variables. So what we want to get into is what's a probability distribution. Define what that is, a probability distribution, or describe what it is anyway. What is a probability distribution? It's a way to describe how probabilities are distributed among the outcomes of a random variable. So we're going to describe how probabilities are distributed among the outcomes of a random variable. So when we're talking about a discrete probability distribution, remember the outcomes are only going to be counting values. So for a discrete probability distribution, what we usually use, often tables. Use either tables, like a chart, or sometimes graphs. Sometimes you'll see like a graph, sometimes a histogram graph, or sometimes equations. I don't think we'll do any equations in this class. I'm just going to probably stick with tables and graphs, probably just tables and graphs for our discrete probability distributions. But you can also use equations, and we're not going to get into the equations. We get a little too advanced for this class. So let me just give you an example of a discrete probability distribution. You get a feel for one. Okay, so here's an example. So my random variable I'm going to call x. It's normally what you call your random variable. It's like a capital X. Capital X. Let's say it represents the number of children that couples have. Let's say selected couples. So let's say I randomly select a couple, and I figure out, okay, how many children they have. What's the probability? What's the probability for having so many children? That's the idea. Number of children that couples have. All right, so here's the probability distribution. It's going to be in the form of a table. So here on this side we have our x. So x represents the number of children. And let's say x goes from 0, 1, 2, 3, 4, 5, 6, 7, 8. So I guess here the maximum number of children that could be had would be 8 children. So you can go from having 0 children to 8 children. So this is a number of children that couples have. And on the right-hand column, we're going to put the probability of having so many children. We call this P of x. P of x. So let's just pretend that for having no children, you have like a 25% chance, if you're a couple, of having no children. So if someone randomly selects a couple, the probability is 25% that they don't have any children. For one child, 32%. So 0.32. We were going to write these all as decimals. Probabilities we write as decimals. 3 children, 23% or 0.23? No, that's 2 children, right? 2 children, 0.23. 3 children is 0.12. That's 12%. 4 children, let's say, is 0.07. 5 children is 0.005. So that would be 0.5 of 1%. 6 children, the probability of having 6 children, 0.0045. 7 children is 0.00043, and 8 children, I don't know what happened there. 8 children, that's the limit we're having here for this situation. 0.00007. Okay, so what do you notice here? Notice that first of all, okay, so this is supposed to be a discrete random variable x. X is our discrete random variable. Right, it only takes on whole numbers. Only counting numbers, 0 through 8. On the right-hand side, you have your probabilities. So this table here is our discrete probability distribution right here. This is a discrete probability distribution. So what does this distribution tell us? It tells us how the x values are distributed. So notice that the x value that has the most weight here, 32%, is 1. Right? So it looks like having one child is going to be the most likely to be the most common. And there's a highest probability of happening. Okay. So some things about this. Some things you'll notice about that is, number one, the x values. X takes on counting numbers. Right? So anytime you're talking about a discrete probability distribution, the random variable x has to take on counting numbers. Number two, if you look at the probabilities, the p of x, the probabilities are never negative and they're never bigger than 1, right? The probabilities are going to always be between 0 and 1. So p of x, the probabilities, remember probabilities are always from 0 to 1. We said that earlier on our introduction to probability, I think back in 4.1. So p of x, let's just say p of x is between 0 and 1, is from 0 to 1. It's an important fact. And number three, if you were to add up this p of x column right here, if you add up these numbers carefully, you're going to get exactly 1.00000. In other words, 1. So the probability should add up to 1, right, which is 100%. That's the maximum probability you could ever have for any type of event, would be 100%. Here they all tally up, right? They all have to tally up. So we're going to write it this way. Well, I don't know what happened there. Write it this way. We're going to write the sum. This symbol means the sum. Right? Add up. The sum of the p of x's is equal to 1. That's pretty important. Now, we can actually graph this. If we wanted to graph this, we could. Erase all this here. Make a little graph. To the side. Okay, here's my graph. Okay. So notice I have x goes from 0 to 8. So here on the bottom, I'm going to put my x. It's my random variable. And the values go 0, 1, 2, 3, 4, 5, 6, 7, 8. And my p of x. Let's see, it goes up to 0.32. We should probably go to 0.35. So what should I go by? I'm going to go by 0.5s maybe. It's an idea. 0.05. 3, 4, 5, 6, 7. Okay, I'm going to start here. This is going to be 0.00, 0.05, 0.10. Let me get rid of this red boundary here. 0.15, 0.20, 0.25, 0.30, and 0.35. And that's all the farther I'm going to go with this. This is going to be called the p of x. Should have left myself a little more space. So I should be, let me put p of x up here. So p of x is the vertical axis, and x is the horizontal axis. And now what we're going to do, some people put little bars. I'm just going to put lines that go up and then a little dot on the top. So for 0, we got 0.25, right? So I'm going to go up here and put a, oh crap, erased my stuff. Okay, let's use a red, there we go. So I'm going to put a little line going up to 0.25, and then I'll put a little circle, like that, little dot. Okay, for 1, we have 0.32, so I'm going to go up here and almost halfway between 0.30 and 0.35. That's about 0.32. What about 2? 2, you have 0.23 as the probability. That's about right here. Draw a line down like that. 3, we had 0.12. That's 12%. That's about right here. Draw a line down. For 4, we had 0.07. That's between 5% and 10%. That's about here. Draw a line down. What about 5? For 5, we have 0.005. That's way low. It's like right here, right? It's less than 0.01. Less than 0.01, 0.005. And then we have 0.0045. That would be a little smaller. And for 7, we get tiny, really tiny. For 8, we get really tiny. So this is the probability distribution as a graph here. So what you can imagine is you have like 1 pound of weight. And you have, so that's like your 100%, right? 1 pound of weight is your 100%. And you have to distribute that weight between these different values from 0 to 8. So you're going to break it up. So 0.25 of your weight, you put on 0. 0.32 of your weight, you put on 1. So on and so forth. 0.23 of your weight, you put on 2. Right? So on and so forth. Yeah, we call it a probability distribution because that's the way our weight is distributed. So most of the weight you can see is on 1, right? Most of the weight. It's going to be the biggest weight is going to be on top of 1. Now some people, they actually make bars. They'll actually go ahead and make bars like this. And they'll shade them in and say, okay, that's a weight there. And they'll take this one and they'll shade that one in. And they'll say, oh, that's a weight there. But I'm not going to do that. I'm not going to do that. Okay. So there's an example of graphing a probability distribution. I don't think we're going to do any equations with these. You can come up with equations, but